Good afternoon, everyone. Welcome. My name is Roger Frechette. I'm a managing principal at Interface Engineering and would like to thank you all for logging in today. Welcome to our Interface Engineering 2024 Educational Webinar Series event. And we've got a great show for you today. Today, the topic is what's new with the GSA P100 Facilities Standards. So anyone working on government work, working on GSA projects, we hope you'll have some good takeaways today. So today we're using a GoToWebinar meeting platform. So today's presentation will be recorded and will be made available through our website in case you missed anything and would like to go back and take a second look. So all audience microphones will be muted during the presentation. However, we would invite you all to enter questions into the questions portal that you should find in the menu in the upper right-hand corner of your screen. And at the end of the presentation, we will answer as many questions as we can. If there are leftover questions, we will record the questions and the answers and distribute them to all of today's participants. So Interface Engineering is an approved AIA CES provider. So for today's participation, you will earn 1 learning unit. All attendees will receive a course completion certificate, or if you've provided an AIA number for attendance, your attendance will be reported for you to AIA within the next 2 weeks. So we have a lot of material to go through, but we'll try to leave at least 10 minutes at the end of the presentation for your questions. And I guess I would like to turn it over to 2 of my colleagues, Teresa Rainey, who's an associate principal at Interface. She's a licensed professional engineer and a lead fellow, and Kulai Salitra, associate principal at Interface, professional licensed electrical engineer. Teresa, take it away.
Super. Before we get started, I wanted to just do a brief overview about Interface Engineering. For those of you who are not familiar with us, we are an MEP consultant firm that covers a broad spectrum of market sectors. Our services are very broad, from conventional MEP design to commissioning and lighting, daylighting analysis, and energy modeling. I think what we're most known for is our sustainable design, and we've got a record number of 85 net zero energy buildings in our portfolio. We are also a national firm with 10 offices across the US. So now let's launch into the course itself, and I'm actually going to turn my camera off so that you can see the full slides. So learning objectives, again, as Roger said, this is credentialed project, or presentation. So we do include the learning objectives associated with this presentation. So the agenda, what we're going to cover is this new P100 Facility Standard, the latest version. Really do an overview about the standard itself, talking about its application and how it's structured. Then we'll get into a deep dive into those major changes that have happened in this version, along with summarizing really, I think, the major, in my opinion, the section that's been most impacted, which is the sustainability chapter. We'll follow up with some project examples, things that we've been involved with as applying these new standards, and then leave it some time for questions. So launching into it, the P100 is the facility standard for all GSA-owned real estate. It is a mandatory standard. It's not just a, good ideas, guidance, but it is to be used, with codes, governing codes and standards. The whole updating process, it's on a similar cycle to our typical codes and standards, this 3-year publication cycle, but the actual process of updating the standards is a year-long process. It's led by Lance Davis, the P100 program manager at GSA, and he works closely with the GSA steering committee, a green building advisory committee, and industry, really reaching out to those leading, seeing the leading edge of what should be incorporated into the standard, and a lot of promoting these P100 change request form. So I know he sends out a lot of blasts encouraging everybody to submit change requests. That also includes language that you would specifically want to see in that update. There is a link within the P100 for anybody to go ahead and submit your requests. One of the things that we've learned is they're also this year did a more of a rollout schedule. In the past, the P100, when the latest version is, truly required, I think had been more, maybe more loose, but this time around they had a schedule where they published it in the end of May, and then by July, projects that were like in study phases, it was applicable, and then by August 1st, any new solicitation, it was a requirement. And this is applicable to all GSA-owned regardless of the funding. So clarification on the project types regarding new construction versus repair or alteration. And they've also provided guidance that even in lease construction, if the government has the intent to own it or an option to purchase it, it may be applicable. But critical is it is not retroactive. Within the P100, the facility definitions from the building codes, there was a little more information provided on critical action facilities, especially regarding floodplain management information, and then mission critical facilities. They included this Federal Data Center Enhancement Act information. I mentioned the governing codes and standards. So P100 is intended to be used with national codes and standards, and more, I'd say, clarity on the latest published edition of those standards, not necessarily the local jurisdiction, if they've what code version they've adopted. And this is taking that perspective of the GSA knows it takes a while until the project is completed construction, and typically by then that latest standard is now in place. And so thinking ahead on the life of their buildings, they want to make sure that they're designing in accordance with the latest published versions. Again, no difference if there is a conflict between the P100 and the codes and standards, bring it to the attention of the regional project management team. All right, the structure. So how the P100 is organized regarding criteria. It includes performance tables and then performance attributes that are really tied to those tables. So a little more context about the performance requirements. But then there's a section for prescriptive requirements. So it's similar to the national codes where there's a mandatory, a prescriptive, and a performance-based. And each of the chapters are structured with those major sections. An example, I'm pulling from the mechanical section on the noise control. So when you look at a performance table, there is also tiers of performance. There's a baseline, and then up to tier 1, 2, and 3 that just gives ever increasing performance thresholds. When you go to that performance attribute section, again, a little more information associated with the performance, why it matters, what is the aspect of that performance criteria that is important to GSA. And then that prescriptive requirement. So majority of the P100 is performance-based. So it's really those tables and the performance attributes. But there is still these sections on those prescriptive requirements. When we look at the overall chapters, of the P100 is pretty comprehensive. I mean, it covers everything in the design of a building, all disciplines, including their special spaces. GSA has a lot of land port of entry and courthouses, so including the criteria and associated guidelines for those specialty spaces. And then an appendix with a little more information on BIM, the building information modeling, and cost structure. So I talked about this change proposals. So GSA received over 750 change proposals, and most of them were in the cleanup, clarification, or updating standards. But this chart really gives you a perspective of where the comments were coming from, what categories. And sustainability, electrical, really are at the top. And I think that kind of gets into some of the topics we're going to discuss, which is electrification and honestly, the sustainability chapter and the organization of it. High level summary in chapter 1, the general requirements is where most of the sustainability is identified. So restructuring that chapter, pulling in pieces that were in other sections so it's a more comprehensive, and really aligning that chapter so it looks like the other chapters. On the architecture and interior design, it was enclosure. They focused on thermal bridging and air tightness. Testing procedures was a big facet. Again, really sustainability related. Structural and engineering, there's some licensure I'll talk about in a minute. And then mechanical, electrical, a lot of the electrification and energy performance, smart buildings. So structural and civil, in the licensure component of this, they now have included this requirement that the designer, engineer of record must be licensed in the state, district, or territory of the project location. And we've actually been seeing this across a lot of the projects where even MEP, they want licensed engineers in the project location. So my presentation here is really focusing on those areas of the major changes, which is going to be sustainability. We'll start with that. And then we're going to move into the electrical sections, lighting and power, with a wrap up on the EV, so the electric vehicle supply equipment. So let's dive into it. So I mentioned sustainability, the chapter's been restructured. This is a summary of all the changes, and the bolded sections are all the new sections that have been added into this P100, more clarification, a little more definition, especially when it comes to materials. So deeper dive, when we're talking about energy net zero, not a lot has changed here other than the restructuring, but baseline, it's a lot more focus on designing for that net zero energy, reducing the building's energy consumption, but then identifying opportunities for renewable, locating it on the plan so that future projects can incorporate that renewable much easier. When we move to tier 1, it's 25% of renewables on site, but there's also this requirement from the International Green Construction Code that you're meeting the minimum thresholds from the tables in IGCC, which for an office building would be 14 kBtu per square foot per year. When we move to the next threshold, tier 2, it's 50% renewables, tier 3, 100%. The water net zero has really had a big impact in a change. It used to baseline just meet the ESA 438 requirements. They have now added that new construction projects must have a 15% potable water reuse or infiltration on site. And when they're moving to tier 1, that threshold increases to 40%, but they pull in major modernization projects needing to meet the 15%. Tier 2 moves to a 75% for new construction with 40% on the major renovation projects, with Tier 3 being 100% for new construction and 75% for the major modernization. You know, definitely and we've been experiencing it, rainfall events, there is a big focus on water use reduction. GSA has their Green Proving the Green Proving Ground program, which they've renamed in this P100 to their pilot to portfolio. It's like their high performance technologies. So if you are not familiar with this program, they have done a fantastic job of issuing reports on performance, you know, findings of these pilot projects to help better, you know, integrate implementation into their portfolio. What they've done is increase the number of these technologies that they want to see in their projects. So now the baseline is a minimum of 2 Green Proving Ground or pilot to portfolio technologies. At the Tier 1 level, it's 4, Tier 2 is 5, and then Tier 3 is 6. And again, there is a lot to choose from, so I think it's a pretty easy ask, but definitely tap that resource to identify applicable strategies for your project. Electrification is definitely a big change, so a lot more definition regarding when it's applicable. This flow chart that I'm showing is directly out of the P100, which really helps from how the project is funded to then understand, you know, what technologies are being replaced and when electrification is required. Definitely a focus on eliminating the fossil fuel burning equipment for HVAC, domestic hot water, on-site cooking, laundry, and demand response generators. Emergency power generators are excluded from this requirement, and there's more definition in the life cycle cost analysis portion of the appendix that explains what they want to see within the analysis of the options, all the alternative systems that are explored early in design. I would encourage everyone to look at this, because even with electrification, that costing needs to include if you need to upsize your electrical service, right? There is going to be an impact, and so it needs to be comprehensively including those impacts. But they do also emphasize that of the alternatives, heat pump technology needs to be one of those technologies that's included in an alternative. If you do not meet this requirement from various ways, meaning if the table that's shown on the left where the P100 says in this type of a application you must be electrified, and for some reason the project is challenged to do so, you have to receive a P100 waiver. That also includes if you have a central system that you're using steam, hot water, or chilled water that is a fossil fuel burning equipment, you need a P100 waiver. And if you've done the analysis and it's demonstrated that it's not life cycle cost effective, you need a P100 waiver. The waiver needs to include that whole life cycle cost analysis with at least one, one of the alternatives being a heat pump technology. But critical to this is this clean energy rule. You need to demonstrate that you are meeting that 90% on-site fossil fuel reduction beginning in fiscal year 2025, which is the AIA 2030 challenge goals, as we're all familiar with. We reached that 90% reduction level in 2025. All right, I'm going to shift now to materials. I think this was the other big section where changes have been incorporated or requirements have been actually bolstered within the P100. So there's always been a focus on prioritizing material selection, looking at the durability, the life of the material, and the low maintenance aspects. but also recycled content, and or if the material is recyclable, so it can continue to serve a purpose in the future. More now is this ability to disassemble, uninstall it, be able to reuse it in its state in another application, and then also the local sourcing to reduce the transportation emissions associated with the materials. The section on holistic approach of regenerative materials is really getting into those EPDs, right? So make sure you're selecting products that have an EPD that really help reduce those negative embodied impacts. You know, focusing on human health, social health and equity, the ecosystem health, and the circular economy. Salvage materials, again, even, you know, in projects that have a demolition, is there a way to demolish so that those materials can be reused in another life? Finding partnerships in the marketplace where salvage materials could be used in your project. There are databases, and I think we'll see, I think this requirement is going to help launch more ability to understand resources and sharing what products might be available for salvaging or reusing. Sustainable wood, really the tracking, so the responsible sourcing of wood. So any project that is using wood needs to make sure that that material has been documented following this ASTM D7612-21. So really helping to know that it's being tracked and sourced in a responsible manner. They have included resources like this, sites where they're encouraging you to look at other opportunities of how to find materials and tracking of the wood products. And the last new category is this with the PFAS. So GSA is always trying to be a leader, and they're strongly encouraging, you know, products not use materials that have been regulated by EPA, you know, with the PFAS for interior finishes. It even is getting into some of the fire protection systems with the suppression systems. So being aware of where, you know, the materials that we're using, thinking about the human health is important. I think the other big category under the sustainable materials is sustainable construction. So they've always had a requirement about certified green certification of construction personnel, but now they're kind of bolstering that to include that contractors have a plan and a commitment for the work site, not just the installed materials within the building. So anybody who's familiar with Building Green Sustainable Design Leaders group, there is a sustainable contractors leader group that came together to develop this contractors commitment. GSA is requiring that contractors on GSA projects meet the good level of this commitment because it's addressing carbon reduction on-site, job site wellness, the waste management, how water is being used and managed on the site, and the materials that are not permanently installed but used in the construction process. I think the other important thing is there's been a lot of new developments in off-site construction, new standards being developed, and there's an encouragement to look to off-site construction because of its ability to reduce materials and then the impact it has on the community. We're going to switch to electrical. So, Kulai.
Yes, I'm here. Hi, my name is Kulai Salitre. I'm an associate principal with Interface Engineering, and today I'm going to talk about the small updates that been taking place in the chapter number 6 of the P100, lighting, power generator, and after that go to The big new chapter that has been added to the P100 in 2024, which is the chapter 8, which talks with the electric vehicle supply systems. So I'm going to close my video just to make the presentation bigger, so for everyone to see. So the couple of changes that happen in the lighting is that for interior lights, all the product that are being specified, they need to meet the Design Light Consortium version 5.1 from 5.0. The exterior lights shall meet Luna 1.0. And in case where luminaires do not meet the DLC requirements, example, decorative fixtures, the lighting designer has to evaluate on a case-by-case basis. The new 2024 standardized the digital protocol that is used now at DALI 2, digital addressable lighting interface, and they introduced the digital addressable lighting interface for IoT, and they call it D4I, because of the introduction of the power over internet that it's coming on the market, and GSA wants to use it on some of the on of the projects. If those projects that you are working on, you are going to use the power over internet systems, then you have to follow the requirements below, where you are required to use the red cable for the emergency lighting. You have to comply with UL 924 for the emergency lighting. You have to make sure that the cable used for normal lights are a different color than the IT cables. You have to use lengths that are limited to 328 feet. You have to comply with IEEE 8023BT Class 8, which allows you to go up to 90 watts on that cable. Of course, you have to comply with the new article of Nationality Code 725 and 840, and all luminaires shall be provided with dedicated drivers. Although is not included in 2024 P100, there is a new player on the market that is called XPOA, and for that player, you don't have to have dedicated drivers to each lights, because the driver itself is located in a central location inside the LAN rooms in the racks. So that makes the POA system, or the XPOA system, much flexible and easier to install and maintain. When you are using the POE systems, the GSA is going to provide and manage those POE switches because of the security issues that they have. These are the changes on the lighting. We go to changes on the power, where right now they are requiring that all 1200 amps and larger service switchboards, or to become actually switch gears, by UL 1558 for service entrance. So any services that you have there and the 1200 amps or more, they need to be, it's a must, they need to be service entrance switch gears, no more switchboards. Wall switch gears and switchboards must have hinge covers in lieu of removable covers. So that helps the maintenance crews to make sure that, by mistake, they are not going to drop the removable covers in the breakers and create unsafe conditions. They provided clarification on demand load, spare and space capacity. The demand load requirements on P100 and space and spare are for new construction, new equipment. So those numbers, 25% spare, 35, 30, 50% space, Those are for the new equipment. If you provide a new service and a new building, you have to provide those demand loads. You have to meet those spare and space capacity. If your project is an existing building, you make use of whatever has been provided as a demand load, as a space and spare capacity. You don't have to maintain that to an existing equipment. But if you are adding a new equipment, panel board, switchgear, motor control center, those requirements on demand, spare, and space capacity, they have to be followed. It's a must. Another updates that have been done on the elevator and vertical transportation. The critical control circuits that are installed in elevator pits, they have to be positioned in a such way that will be protected from water intrusion during flooding or sprinkler activation. All elevator controllers must have a short circuit current rating. This is a requirement of National Code. It's a requirement of P100, and you must have to do it. So the existing manufacturers right now, they went from the minimum 5,000 amps on their controllers to a 10,000 amps control, which helps. But there might be situations where your elevator control room is very close to the service, and your short circuit calculated is going to exceed the short circuit current rating of these panels. The moment you see that, make sure that you coordinate with respectable parties and make sure that your short circuit current rating of the controllers will be upsized to whatever needs to be. The shunt trip circuit breaker or current limiting fuses have to be provided when sprinkler systems are present in the machine rooms and elevator shafts. On the generator, the small changes that they have is that if somehow the emergency power supply system is 1200 amps or larger, now it needs to be an UL 1558 switchgear, similar to the service. The switchboard is no longer being permitted. And because of the switchgear, it needs to be provided with IR, infrared camera port, on the enclosure for easy inspection in thermal problems while under the load. Also, all switchgears and switchboard panels have to have the hinge covers in lieu of the removable covers for safety purposes. The size of the generator for diesel has been increased from 350 to 500 kW. Now, natural gas, it's allowed up to 500 kW, and diesel, it's allowed from, it's recommended from 500 kW and more. Also, in 2014 P100, the load bank has been clarified as a size, and it's indicated that regardless of the type, fuel, natural gas, or diesel, you are required to have an automatic load bank controller that is sized for natural gas 20% of the label size or 50% of the label size for the diesel generators. The biggest change in the electrical section was to take the electrical vehicle supply equipment from chapter number 6 and move it to a new chapter called chapter number 8. In this new chapter, they have the paragraphs with EV charging, government-owned vehicle requirements, privately owned vehicle requirements. They have the electrical vehicle supply infrastructure. They have the accessibility charging requirements, and also they have the fire protection requirements, because all government entities do not like to have the electric vehicle supply equipment inside their garages if can be it can be done somewhere else. The preference for installation of EVSEs, it's in this order: outside surface parking areas, roof level of parking structures, all other parking structure locations. If none of this exists in your project, then, and you have parking structure, going inside the parking structure will be allowed, but those parking structures, they need to be provided with appropriate sprinkler systems or other system that will be able to protect the car if the battery somehow catch fire. As all the other chapters, they have the table requirements, and in the table requirements, they have the the baseline tier 1, 2, and 3, and where they are indicating specific requirements by numbers, by type, and what type of levels they need. The minimum charger level that is required in P100, it will be a level 2, that is a 6.6 kW at 2A volts. Let's keep going.
I know we've kind of gone through only a snippet of the P100 and the changes, and I want to invite you to review online. If you go to GSA's P100 website, they have done a great job of going into each chapter and doing their own training videos. So you can download their slides, you can download their videos, and if you have questions, Lance Davis has included his contact information and would invite you to reach out. I know this is a personal passion for him, having really focused on elevating sustainability within the P100. So we're going to switch gears now and talk a little bit about a couple project examples where we've been involved in applying some of these new standards. So the first project is a project here in the DC area. We're not going to name names, just as you all know, the confidentiality of their projects can be sensitive, but it's a historic building. It is connected to the district steam, that GSA's district steam, and the goals for the project through an energy service provider contract was to get to these deep energy retrofit, focusing on energy efficiency, looking at electrifying the central plant, the building downstream equipment, HVAC units, terminal equipment were all to remain, and it all was going to happen while the building was occupied, the renovation work. So the parameters are probably not too unusual to most of you. These are challenging projects, so creatively trying to think of how to solve it. So the existing conditions, as I said, we're getting district steam. The building heating loop is 180 degree to 160. And that terminal equipment, everything tied to it was going to remain. So it was critical for us to make sure we could still provide those higher temperature hot water loop requirements. The domestic hot water, there was different technologies because it was a distributed system. There were some that were steam to hot water converters, and then there were some electric heaters with storage tanks. So our solution was looking at a heat pump technology, but really we were challenged with how can we make sure we're obtaining the 160 degree heating loop with adding an electric boiler as a peak heating source. So if that building needed some additional heat, we could at least get to 170 degrees. We felt the majority, there had been data trending to confirm that we could meet majority of the heating at the 160 degree loop. But what that meant, in order to ensure we could have the 160 degrees, is we needed a source loop that could be regulated. So this 50 to 65 degree loop was needed, And we were able to do it with an air to water heat pump, kind of acting like I call it a condenser water loop. There is a existing outside well that we were able to locate that equipment and then deliver our loop into the existing mechanical equipment room. We looked at the domestic hot water, just making them all decentralized. So electric hot water heaters with storage tanks. The challenge with this approach was not so much how much, well, power, the overall power to the building was a challenge, but I think where the power is delivered was equally as much of a challenge. And I'm going to hand it over to Kulai to dive into those details.
Thank you, Teresa. So this is an existing buildings, existing switchboards. They have some lifetime left in them, not much, but as you may expect it, they already full. There is no space in them for additional breakers. As Teresa mentioned, electrification requires a big chunk of energy and power at the same time. It's not as easy as it sounds, and requires a lot of coordination, field coordination at the beginning of the project. You have to do a lot of deep dive and find maximum demands, electrical bills, information on the equipment. You have to go in the field and maybe hire electrician to open equipment and look at the configuration to make sure that if you need to connect and expand the existing equipment, you have the space and you know the capacity to do it. For this project, as you see, the gray boxes are the existing ones. There is a little bit of space on the left, a little bit of space on the right, that we could have added some sections and to deliver the additional power that we need. This picture really speaks about the demand, the space, and the spare that is required in all GSA projects for the new building. So for the new buildings or whatever expansion you are doing, make sure that you meet those requirements, because the next guy that is coming after you to do another renovation on another project needs to use that space. Luckily for us, after all our investigations, we could add 2 new sections, switchboards, and we could deliver the required power to the new HVAC equipment that is somewhere outside, and everything was working fine for us. But think about this. GSA right now require electrification on their buildings. In the same time, the DC require electrification on the entire city. At one moment, the infrastructure of the PEPCO, BG&E, or whomever will be the distributed utility is going to get to full capacity, and probably, issues may occur on the outside distribution. So I encourage everyone to look kindly from the electrical perspective and electricity in their designs, and make whatever it takes to use super high efficiency equipment, and make the just a less impact into the distribution of the city as possible. The lesson learned, electrical speaking, is that the electrification require an increased overall load to the building. No matter what you're doing, if you are doing electrification and you have equipment that is using fossil fuel, your overall demand of the building is going to be increased. You are going to need new distribution to deliver power to the outdoor equipment, whatever you need. Teresa, now you can talk about.
Yeah, no, absolutely. And on the heat pump side, I mean, because it was an existing building that was remaining operational, they had a 24/7 chiller. We could have probably had a more creative 6-pipe heat pump system, but our equipment needed to be additive, to what was already there. So a lot of our challenges were, maintaining that high temperature heating loop. It required us to look at a creative way to regulate that source loop. And this was a solution that would work. So those were really, I think, our lessons learned. And where we had space available to locate that equipment was also really important considerations in just incorporating it so that it's not visible, that it met the project requirements. I think our next project we want to go through is more electrical, solar. So this was another energy service provider contract project on a campus level. So they were looking to incorporate a solar PV, not only in canopies, but also on some of the building roofs. We're asked to look at a battery energy storage system and incorporating some new EV charging stations. Kulai.
Yeah. So when we visited the site, we did the study for the PV. We had a couple of meetings with the contractor, and we came up with an optimum solution for the PV system. As you can see, the blue ones represent the PV array. So the existing distribution system, has the utility and a generator with a single automatic transfer switch. The generator is able to power the entire campus. By adding PV battery storage, we will help with reducing the consume of the fuel, the diesel, when needed. Our idea of the design to help them and increase also the reliability of the system is to provide a microgrid controller, and this microgrid controller will give them the ability to isolate themselves from the utility when needed and operate independently when pretty much as they can and as much fuel they have. Another requirement was to provide EV chargers in the parking lot. We identify the the location where those EV chargers will be connected. The battery system was a containerized solution that is located between, near the main electrical room where the generator and the main switchboard is located, and the integration of the PV battery and microgrid controller with the existing infrastructure, it's seamlessly and will help them to achieve their goals. The lesson learned. What we learned here is that being a campus and having so many buildings, we try to understand, the maximum demand of each building because they had only one single meter. So was quite difficult because they have an existing submetering data, but unfortunately it doesn't work. So we had to do a lot of study, a lot of calculations to come up with a reasonable, peak power load demand that can be used in determining the size of the, PV battery, and make the microgrid design cost effective. This campus, as many other buildings on the GSA portfolio, they didn't have a lot of drawings. They had some, but for some of us, we had to go in the field, open equipment, pick up, use our extensive knowledge and experience, and come up with a complete power distribution that can be used in the future by others. That's it.
Yeah, so we want to open it up to questions. I think I notice that we've indicated to add some questions into the chat. I'm not seeing any. I would invite any and all questions.
Okay, well, I think the presentation was so very thorough that there are no questions. But if there are, but if any come up, please send them along. You can continue to add them to the questions portal, and we will be sure to get those questions responded and distributed. So I would like to thank Teresa and Kulai for doing such a great job with the overview of the new P100 facility standards and providing those great project examples. Did a great job of explaining all the materials. And I'd like to thank everybody else for participating in today's webinar. We hope that you found it to be informative. And please, I would like you to keep your eyes out for the next interface webinar, which will be held in just a few weeks on November 19th. It'll be a discussion regarding the new refrigerants, which will focus on the challenges associated with the EPA's phase out of refrigerants which use hydrofluorocarbons and how these changes will impact your projects. So thank you very much and have a great day.